Hi guys, hello guys, welcome back for the 100 days challenge of NEET and as well as JEE program. We'll start with the topic. Like today's topic is angular momentum and conservation applications we are going to see, right? So let me open the PPT here. Okay, just a minute, it'll get it. Once it's open, no, we'll start. That's it guys, it will open. We'll start with the classes. Yes, so we'll start with angular momentum first. Like what is angular momentum and what are the applications we are going to see, everything we'll see in that class. Okay, what is angular momentum? First thing, angular momentum is the rotational equivalent of a linear momentum. We have studied about the linear momentum, right? What is linear momentum, how it has been denoted? So linear momentum, see, it is denoted by denoted by P, that is mass into velocity, right? That is linear momentum. I'll mark it here, it is denoted by P. I have written the formula also, mass into velocity. It describes the quantity of rotational motion of a body possessed about a point or axis. So when we are talking about a momentum like linear momentum, one dimensional we will see, but angular momentum, it is due to the rotational. Now we will see how we denote that. It is denoted by the letter L, angular momentum. Okay, so L is nothing but R cross P. Like about a point, no, we are taking, or a point of axis we will take. So R cross P, where L is equals to R cross P, where R into P is nothing but mass into velocity. Okay, so if I want to remove the cross symbol, no, that is mvr sin theta. This is the formula, guys. This is the formula, mvr sin theta for angular momentum, or else L is equals to R cross P, where P is nothing but linear momentum. So for rigid body, L is equals to I omega. We know that P is equals to mv, like mass into velocity. Instead of mass, I will take moment of inertia. Instead of velocity, angular velocity. Right, unit is kg meter per second, meter square per second. Okay, for this guys, only for this thing. But what about the unit for this? Mass, that is kg, velocity, meter per second. That's it. Okay, why meter square per second? No, this is kg and this is meter per second. Again, this one is meter, right? So kg meter square per second, that's why. And dimension is ml square t power minus 1. M mass, L, that is meter, L square, no, this is mass in meter into meter, L square t power minus 1. Okay, this is about the angular momentum. We will go for the next slide. Law of conservation of angular momentum. if no external, like conservation is in the sense like when there is no external energy or any force, no, then it will be conserved, we will say, no. Like if no external torque acts on a system, the total angular momentum of a system remains constant. Okay. If net external torque, that is 0, angular momentum is conserved. Okay, angular momentum is conserved, we will say. So torque is equals to dl by dt. Okay, angular momentum with respect to time, we will say, no. So if torque is 0, L is constant. If torque is 0, angular momentum is conserved, we will say, no. So I1 omega 1 is equals to I2 omega 2. So example, body changes shape, orientation, shape or orientation. Okay, this is about the law of conservation of angular momentum. Next thing, physical meaning, like angular momentum is conserved when no external torque acts, just like linear momentum is conserved when there is no net force. So for this linear, no, we will talk about force. Yes, we have studied about torque in the last previous class, no. Yes, so force for a linear but torque for angular, Now applications of angular momentum conservation. First one, high skater effect, like arms stretched, larger I in the sense moment of inertia will be more when arms are stretched. Okay, in skating guys, in skating, okay, that's why I gave this symbol here to understand that. Okay, in skating, like if arms are stretched, okay, larger I, moment of inertia will be more, so spin will be less, slow spin. One, we know that L is equals to I omega, right? I can say I is inversely proportional to omega, right? If I increases, omega decreases. So arms are pulled, I will be less, omega will be more, like velocity will be more. Okay, when arms are stretched, no, like arms are stretched, angular velocity will be less. When arms are pulled closer, omega will be more. So I omega is constant, that is L is constant. Okay. Next thing, neutron stars, when star collapses, radius shrinks drastically. So I decreases, they have said, I have written I decreases. If I decreases, what happen? Omega increases. Shrinking, like that's what, when pulled towards, no, like coming closer, then what we will say? Angular velocity increases, moment of inertia decreases. When you are going away, no, moment of inertia decreases, increases, angular velocity decreases. Only reverse thing, coming closer, moment of inertia decreases, velocity, angular velocity increases. Going away, moment of inertia increases, angular velocity decreases. Angular velocity increases enormously, that's what I told. See here, angular velocity increases. So conservation explains rapid spinning of neutron stars. So like questions can be in this form, ice skater effect, neutron stars. Okay, next I will say some more things are there. Cat turning in mid-air, like a falling cat can rotate and land on its feet. Like a cat is falling, no, like it's rotating and falling, they will say. So no external torque, so it's reorients using internal body shape changes. So L remains conserved there. Okay. Next thing is planetary motion, that is Kepler's second law. We will study about that, okay, in the upcoming classes. So planet sweeps equal area in equal time. This one especially we will see in gravitation in the next lesson, okay. Due to constant angular momentum, no external torque from the sun, okay. Mark this guys, we will especially see about the Kepler's second law in the upcoming classes of the 100 days challenge, okay. Disk bullet problem, okay. So these kind of problems can be also asked, like bullet embedded in a rotating disk, So use L initial is equal to L final, okay. Moment of like angular momentum is conserved, okay. So use this. Angular momentum initial should be equals to angular momentum final. I need to use that. So final angular velocity omega is equals to mvr by I. Okay. Next, rotating stool with dumbbells. Like most of the illustration we have seen that like a person is rotating in a chair or a wheelchair by using dumbbells in both hands like this or either like this. So person rotates slowly with an arm stretched. Arm stretching in the sense moment of inertia I need to see, like pull arms in this case moment of inertia increases. Stretching, no, stretching in the sense I told moment of inertia increases, omega decreases. Pulling in, moment of inertia decreases, omega increases. Okay. Next, so these are the strategies you need to look into for JEE mains as well as NEET. You can see once, practice numerical derivations, focus on torque, rotation, moment of inertia, apply in system like disc, pulleys. Okay. And then focus on conceptual understanding, understand no torque, that is L is constant. Think in real world analogies. Okay. Like these are the strategies you need to follow when you are solving the problems in JEE mains as well as NEET. Okay. Okay. Here is the first question, guys. A bullet of a 40 gram is fired horizontally with a velocity of 160 meter per second from a pistol weighing 2 kg. What is the recoil velocity of a pistol? Simple, guys. Like we have discussed about the angular momentum, right? It's the question based on the linear momentum. Once you can solve this, like I told that using moment of inertia, that is final initial, like I will write here linear momentum final should be equals to linear momentum initial. Okay. So final thing I need to get it, like a bullet mass 40 gram, no, mass of the bullet is 40 gram, which is nothing but 0.04 kg, right? And then mass of the pistol is given, pistol is 2 kg, and velocity of the bullet is given there, velocity of the bullet is equals to 160 meter per second, 160 meter per second, and I need to find velocity of the pistol here, velocity of the pistol I need to find. So initially what will be the velocities of both? It is 0, right? Velocity, initially velocity is 0. Like I am holding this gun like this, initially 0 velocity. After shooting, no, velocity of a bullet goes, after recoil the bullet, like a gun will come back, right? So that's the thing. So for this initially momentum is 0, like I can say mass of the bullet, velocity of the bullet plus mass of the pistol, velocity of the pistol. Like velocities are 0, no, so I can totally neglect it out, so it's totally 0. So from this I can say that 0.04 into what is the bullet velocity, 160 plus, and then 2 into velocity of the pistol should be equal to 0. Now what I can say, Vp is equals to, if it goes in the other side, minus 0.04 into 160 divided by 2. So if you solve that equation, guys, you will get the answer. That's it. It's a simple thing, guys. You will get the answer. So once this is 80, so this one will be 3.2. but in minus. So minus 3.2 is the answer, guys. Minus 3.2 is the answer. Okay, we'll go for the next question. A man is sitting on a rotating stool with his arms outstretched. If suddenly he folds his arm, the angular velocity of the man would. Okay, look in the question and you can answer it easily, guys. This is the easiest question. So one of the question asked in NEET PYQs. See, initially like stretching, no, simple thing, guys. Stretching, pulling towards, stretch, pull in, this is pull out. Okay, like these are the terms you need to remember. Stretch in the sense I increases. If I increases, omega decreases. Pull in means I decreases. I decreases in the sense omega increases. Now what they are asking, angular velocity of a man. So when he suddenly folds, folding in the sense increases. They are asking about the angular velocity, not about the moment of inertia. If they are asking about the moment of inertia, I can say it is decreases. I'll give one more question. Similar. A dancer is spinning on a rotating table with his arms extended. If he folds his arm, what will happen to his angular velocity? Similar question, guys. Easy, no? The same type of question, but they have given in different terms. That's it. Extended, folds his arm. Before that, overstretched, pulled in. These terms you need to understand. How you can understand? By solving many questions, you can able to understand what are the terms they are using there. Okay, so dancer spinning on a rotating table with his arms extended in the sense I is increases, I increases in the sense omega decreases. If he folds his arm, the what will happen? Folds his arm in the sense, so initially he is like this, next he folds his arms like this. Okay, I decreases, omega increases. So angular velocity increases. If they are asking about moment of inertia, what happens to moment of inertia? So decreases. Okay, if they are asking about moment of inertia, decreases. Next question we'll do. Okay, guys, I'll give in the question in the chat box. You can solve it and give. Okay. Until then, bye bye, guys. We'll see you in the next classes. Bye. See you.